Lesson 28, Quadratic Application and Regression. So we're going to do some more word problems and then talk about the regression of the calculator. So you will want your calculator for this one as it's needed. Okay, example A. Imagine we had a swimming pool that was 6 meters wide and 10 meters long, and then we're going to surround it by a walkway with a uniform width. So I'm going to label what we just read. We read that this is 10 meters long and 6 meters wide. We also were told that the distance here is going to be the same as the distance there. So all the way around the pool, we're going to have the same sidewalk essentially around it. We know that that's W. So we're going to put a W on each of those sides. Essentially, I'm going to do it on all sides so I see it. And we have this happening. Okay, so part A. It says write a function A of W that describes the area of the walkway as a function of W, the width of the walk. So in terms of this, we know that the area of the walkway is going to be the bigger rectangle, right? We're looking for the area of this here, the big blue part. But I just want the walkway. So doesn't that mean that I'm probably going to have to get rid of the area of the pool? I don't want the pool in my area. I just want the area of the walkway. So to do that, I have to think, what's the distance of this corner to this corner? I know one side's W, and then I know the distance of the pool is 10 meters, and then I know the other walkway part is W. So I would have 2W plus 10. And then in terms of the other side, this side here is going to be W plus 6 plus W, which again is 2W plus 6. So in terms of the area of the walkway, I would have the 2W plus 10 times 2W plus 6 minus the area of the pool, and the area of the pool is equal to 60 meters squared, as we do 10 times 6, so minus 60. Okay, so I'm going to probably convert that into standard form because it's probably going to help me in future problems. So I have 2W times 2W makes 4W squared. 2W times 6 makes 12W. 10 times 2W makes 20W, and then 10 times 6 makes 60, and then I have the original minus 60. Well, great. I'm going to combine those like terms. My final answer is 4W squared plus 32W. That's the area of the walkway. Okay, so part B. It says find the width of the walkway if the walkway and the pool have the same area. Okay, well, we know the pool. The pool has an area of 60, and we know the area of the walkway is 4W squared plus 32. So we have 60 equals 4W squared plus 32W. Okie dokie. So now from here, I'm going to set this equal to 0. Okay, so 0 is equal to, because I want to see if I can complete this, factor or anything like that. So 4W squared plus 32W minus 60. In this case, I do notice that 4, 32, and 60 all have the number of 4 in common. So I'm going to factor a 4 out. So 0 is equal to 4 times W squared plus 8W minus 15. Now, I don't think anything multiplies to negative 15 that adds to 8. So, in this case, I'm going to quadratic formula to solve for this part B. So, x is equal to negative 8 plus or minus the square root of 64 minus 4 times 1 times negative 15 all divided by 2 times 1. I'm going to grab my calculator, and when I do that calculation, I'm going to get, well, let's double check. I get one answer of 1.567. And then I get a second answer. I'm going to hit second enter so I don't have to type that all over again, and then change the plus to a minus. And then I get or negative 9.567. Remember, x, or in this case w, is representing the width. So if we're talking about width of walkways, we can't have negative widths. So we have 1.567 meters. Okie dokie. That is example A. Example B. It says a rocket is launched vertically upward from the edge of a roof of a 40-foot building. Okay, that's important. So we know that the starting point is at 40 feet. So we can immediately go to our picture. Start it here. We know this is 0, 40. At an initial speed of 144 feet per second, so that is our b value of the function, goes in front of the x, or in this case t term. And then it says using the formula h of t, where h sub 0 plus v of t minus 16t squared, where h of 0 is the initial height of the object, calculate when the rocket will be at 200 feet in the air and how long before it hits the ground. Okay, so they gave us a formula. H of t is equal to h sub 0. H sub 0 is our initial height, so we know that that's going to be 40, can go in the first spot, plus the initial velocity, which is 144 times t minus 16t squared. Okay, we know that our parabola is going to be in this cool downward shape. So we have something like that. And we also know that we're looking for, when is this guy going to be the y value of 200? That's what we're looking for. So I'm going to go to my calculator. I'm going to go to y is equal to, at the very top, I'm going to type in the formula that we just wrote down for our h of t. So I'm going to type this underlined thing into my formula. So 40 plus 144x, I'm going to replace t with x, minus 16x squared. And then I'm going to hit graph. I do need to understand that the graph is not going to give me the picture I have here on my calculator, right? Because on the that I have here on my paper. So on the calculator, remember the y value is only a maximum of 10. So I want to go back to that button window. Remember, window is really important for being able to see things. So go to window, and I want to go to the maximum y value, and I'm going to type in 500. I have no idea how high this thing's going, but I'm going to type 500 just to see. In terms of the x max, I did see it landing, but I'm going to give it a little more room. So I'm going to say the x max is now 15. So I changed the x max to 15, and I changed the y max to 500. Now I'm going to hit graph. I'm going to see what type of picture it gives me now. I have this type of picture, a downward facing parabola. Yes, perfection. So what I want to do is now look at my picture I have on this actual screen, and I have y is equal to 200. So I'm going to go back to y equals, and under y2, I'm going to type 200 and hit graph. And now I should see the picture that I actually have drawn on the calculator. From here, we need to calculate when, so the time, calculate the x value, when the object is at 200 feet in the air. And notice I asked you how many times does that occur? Well, I see it happens twice. It's happening 2 times. One time here on the left and one time here on the right. So it means it gets higher than 200 feet. Great. When are those 2 red dots happening? To calculate that, so it's happening 2 times. And to calculate those values, remember your calculator sheet's really helpful. But if you don't have it, you're going to listen carefully. You're going to hit second and then the button trace, which is the fourth one at the top. In blue, it says calc, so second trace, and we're calculating an intersection number 5. Remember, it's going to put a cursor on your quadratic. You're going to move it slightly close to the left-hand side of this intersection here. So like put it somewhere over there and hit enter, 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 make the calculator do its job. And I see that it's happening at about 1.298, 200. That's the first one. Then I want to calculate again, but I want to calculate the right side. So second trace 5. Move that little flashing cursor over to the right side of your vertex. Hit enter, enter, enter. Again, I moved it somewhere over here. And when I did, I got the value of 7.701, 200. Notice I didn't round, I just truncated, and I'm done. So when does this happen? At 1.298 seconds and 7.701 seconds. And we're done. That's part A. Part B, when does the rocket hit the ground? Okay, so I'm going to go back to y equals. And I'm going to think about this. When does the rocket hit the ground means when does it land? So I could think about drawing another y equals line here and put y is equal to 0, and then do what I just did for the other points to calculate that point of intersection when it lands. So I'm going to change y2 to 0 and then hit graph. I should see this new picture with my yellow line, but on your calculator it might be a different color, on the calculator. And then I'm going to hit second trace 5, move the cursor as close to the 0 as possible, but not really under it. So like, again, kind of like right here-ish, hit enter, 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 and the calculator does its job. And it tells me this is happening at 9.2269, 0. So when does the rocket hit the ground? You can claim that's at 9.269 seconds. Okay, example C. Find the equation of the vertical parabola that passes through the points 2, 3, 5, 7, and -2, 8. Okay, so clear your calculator so that we have some, situation we can get rid of. We're going to go to the home screen. Notice I've given you some directions here. I said regression, stat calc, edit, calc. This stuff is stuff we did with linear functions, but now we're going to do with quadratics. The only thing that's changing is we're going to now pick the quadratic regression point. So I'm going to make a table of values just so I have it, so that I can see it. Like, what did they give me? They could also give it to me not in this nice, fun coordinate way, but they could have said something like f of 2 is equal to 3, f of 5 is equal to 7. Remember, same notation, like same meaning. X is 2 when y is 3, x is 5 when y is 7, x is -2 when y is 8. But you just need to know the difference of notation. Some are coordinates, some are in function notation. They mean the same thing. You just got to decipher what it means. Okay, so we're going to run a regression equation. We're going to go to the button stat on the calculator. Remember, second row stat. Then we're going to slide over and make sure we read it at the top. It's edit, calc, and tests. We're going to work in the edit for a second. So notice it says edit, hit enter. In L1, we're going to type our x values from the table. So 2, 5, and then -2. And then in our L2 column, we're going to type in 3, 7, and 8. Now we're going to go back to the stat button, arrow over to the calc button, and we're going to find where it says quadratic regression. That's number 5. You can either hit number 5 or you can go down to 5 and hit enter. And then it says X list, Y list, and we want to store that regression equation in case they ask us anything. So we would hit alpha trace, or alpha trace 1, enter. Sure enough, it gives you an equation with the parabola's quadratic standard form at the top. Y is equal to ax squared plus bx plus c. So it gives us the value of a. It says that a is, again, I'm going to truncate, but I have 0.369 for a. For b, I have negative 1.25. And for c, I have 4.023. Again, I truncated. I did not round anything. Truncate means, again, go to the thousands place and cut it where it is. So your final equation for this quadratic is going to be 0.369 x squared minus 1.25 x plus 4.023. Now, I didn't get an R value, so I do want to go back through that real fast. If you can go to the mode button next to second, click mode. Remember to turn on your stat diagnostics, and then just hit second, enter, and it'll rerun your regression. It should say under your C value, R squared equals 1. Remember, this means that we have a really strong correlation. In order to calculate a quadratic on a calculator using regression, you need 3 points. If you have 3 points, your R value will always be 1. If you don't have 3 points and say you have like 7, your R value might not be 1, but it still can be strong as long as it's close to 1 or negative 1. Well, folks, that's the lesson at its finest. Good luck on the homework.